Hello, and welcome to Backer Breaks It Down. In this episode, we're going to look at angles formed by parallel lines. So parallel lines are lines that are in the same plane that will never intersect. These arrows, whenever you see these arrows on a line in a diagram, those arrows indicate that the two lines are parallel. And then this is the notation that we use when we want to say that two lines are parallel to each other, okay? So let's kind of like recap these postulates and theorems involving parallel lines. So there's 5 of them total. The alternate exterior angles theorem basically says if you have a set of parallel lines cut by a transversal, then alternate exterior angles are congruent. And here they're showing us one such pair. Okay. Likewise, alternate interior angles are congruent and corresponding angles are congruent. Okay, corresponding angles are the angles where one of the angles is on the inside in between the parallel lines, one of them's on the outside. They're both on the same side of the transversal, but they're not adjacent. Okay. The same side interior angles theorem say that same side interior angles are supplementary, which means they add to be 180 degrees. Same side exterior angles are also supplementary. Okay. So let's use these postulates and theorems to actually find some angle measures, right? In number 1 here, there are 2 sets of parallel lines. So I know like line L and line M, they're both parallel to each other. P and Q are parallel to each other, okay? We want to find the measure of angle 1. So you'll notice that we are given that this angle right here is 105 degrees. So how can we use that angle to find the measure of angle 1? Okay, so we could totally use the fact that angle 4 and that 105-degree angle are same side interior angles. So I'm just going to abbreviate that. So same side interior. And we know that those angles are supplementary, which means that angle 4 would have a measure of 75 degrees. And then angles 1 and 4 are congruent because they are alternate interior angles. Therefore, the measure of angle 1 would also be 75 degrees. Okay. In problem 2, it says in the diagram below, AB is parallel to CD. We know the measure of angle EFG, so that's this angle right here, is 32 degrees. And the measure of AEG, so that's this angle right here, it's 137 degrees. We want to figure out what is the measure of this angle here, EGF. So what are some thoughts? Okay, yeah, I mean, so this angle down here, angle FGD, would also be 32 degrees because these two angles are alternate interior angles and thus congruent. Okay, yes, this angle down here is supplementary to that 137-degree angle, which makes it 43 degrees. And like, yeah, we can totally use the fact that like all 3 angles down here make a straight angle, and we know straight angles are 180. So we know like 43 plus our missing angle plus the 32-degree angle would be 180 degrees, which means that the measure of angle EGF is 105. Okay, so that's how we can use our postulates and theorems associated with parallel lines being cut by a transversal to find angle measures. Okay, and so in our next episode, we'll take a look at proofs involving these theorems. But until next time, this was Back It Breaks It Down.